one. The first question says asking all about the so determine whether some quantities are scalars or vectors. So this is very simple to go with. So now under scalar, acceleration is a vector. Tick. Displacement is a vector. Then potential energy is scalar. Speed scalar. Temperature is scalar. I think that's that on question 1A. 2, question 1B. A constant resultant force F acts on a car of mass M. The car moves from rest with constant acceleration along horizontal ground. When the car's displacement x, the speed of the car is v. So we have to prove the formula for kinetic energy, which is given as 1 over 2mv squared. Now the key words here to start with, number from rest. This one means that u is equal to 0. That's not that statement. Now with the work done, normally the work done, let me use w as work done is equal to what? Force times distance is equal to kinetic energy. So that's to start with. So meaning that we have work done is equal to kinetic energy, which is force times distance. So in essence, we can therefore say kinetic energy is force times distance. Don't forget that force is also given as ma, so meaning that mass a displacement. So that's our kinetic energy. Now we need to go and look for the other parameter to use. We have u is equal to 0. Now from v squared is equal to u squared plus 2as. Meaning, now that means I'm going to have v squared is equal to 0 squared plus 2as. So I can make my ax the solar formula here. If I move that, I'm going to have my as will give me v squared over 2. Then the return. So anywhere you see that, so let's look at it this way. This is as, this is a. So I'm replacing it. So meaning that our kinetic energy is going to give me mv squared over 2. And that's what we have to prove. As simple as that. That's what we have to prove. What are the keywords? Nothing. Just remember the particular formula we according to the question, meaning that from rest. So that's how it happens. Now the question C. So the question is, I think it's nothing difficult because we are just making use of the formula we proved here. So the question said the mass of the car is this. This is the m. So we have the from rest as well. So at time t from 0 to 5.8 seconds. Velocity is now v. This is our v, given as v. So calculate the kinetic energy. So that's substitute, which is 1 over 2 mv squared. So that will give us 9, 2, then multiplied by 17 squared over 2. So pressing calculator. So from calculator, so if we press calculator, it will give us let me just see. So if you press calculator, it will give us coming times 920 2. So that actually gave 132,940. But there's something called the rules of approximation. How do we know the correct one? How do we put it? So I will need to first of all explain that. Very simple to get. Now, if you look at, so if we look at this two significant figure, that means if you also look at this is also two. We don't count this error, so that's also two significant figure, meaning that the lowest one is two. We consider the lowest one, so our answer should be taken to two significant figure. So I'm doing that from here to here. That's give me 13. 1, 2, 3, 4. So that'll give me 1, 3, 1, 2, 3, 4. Or you put in the exponential form, or you say 1.3 exponential 4. Either way. So either way is accepted. It's either you go for this or this. So that's the for to know the correct place. This is 2. This is also 2. That means the lower is 2. Our answer is taken to 2. That's the question. The next one. Now the next one we have between time t is equal to 0 and time t still referring to the same space. The work done against resistive force is this. Okay. Determine the average output power of the car during this time. Output power. Now let's see this way of the car. So let me just have something like this. Let me just say this is the car. Let me demonstrate this. So this is a car. Now, if that is the car, at the beginning here, you have U to be 0. At the final here, which is 5.8 seconds, you have V as 17 meter per second. Now, as a car is moving from, let me label as point A to B, or let me label it that way, so to explain it better. So let me say point A to B. As the car is moving from A to B, so moving from A to B, work is done against a resistive force. That means at the beginning, this at A represent the input energy. B represent the output energy. Now there will be work done along the resistive force before from A to B. So here, by the time the car moves from A to B, the car moves from A to B. So there will be work done along air resistive force. Let me call this one work done resistive force. Yeah, let me label it that way. So meaning that at my output end, I'm going to have, so at my output end, I'm going to have T's and also the work done by the kinetic energy at my output end. At my input end, I only have 0 work done because it's starting with from rest. So my output now, so it's going to now be output work. So that will going to give my output work. That will be equal to work done by resistive force plus work done due to kinetic energy. So work done by resistive force plus plus work done due to kinetic energy. So that's going to be my output work. So this is going to be input at A, output is going to be at B. So at B, I have two types of work done. Work done by the resistor and by air resistance, and work done due to the movement of the car because there is a velocity. I think that is understood. So that will give me, and this is given already 1.7 exponential 4 plus work done by kinetic energy has been calculated as, okay, this should be 5. 1, 2, 3, 4, 5. Oh, 5. If I'm going by this, it's going to give me by 5 exponential 5. So it's not that a must. You can leave it like that. That will give me 5 joules. So that. So that will give me, or that gives us, so that's 1.3 exponential 5. That's just that work done. So power means work done over time. So the power now gives 4 0.7 power 4, then 1.3 power 5, everything over. The total time is 5.8. So our answer will give us, yeah. So let's see what's going to give. Use of calculator. So it's going to give us 30517.2. So it's giving us, let me change to something. It's giving us, so 30517.2. So it's giving us this 30517.2. Now, if you follow our rule again, if you follow that, this, you can see this is 2, this is also 2, this is 2, lowest is 2, taking it to 2, that will give me this, that will give me 30. So that will give me like, no, 31, 0, 0. So that will give me like 31. I mean 0, 1, 2, 3, 1, 2, 3. So that's 0. So that will be what?
A lot, and you're like, okay, do you have a private tuition? Don't you have? Do you have? And yes, Ajiro Tech do have a private tuition. So by my right, you can see that we have for the EdExcel and Cambridge IGCSE, and yes, we do have for all subjects. Okay, all subjects. Okay, the popular ones that's always been in demand is mathematics, English language as a second language. Okay, we have physics, we have biology, we have chemistry, and we have um, you know the flagship, which is ICT, just here and there. We also have business studies. So if you're interested for a private tuition, I think all you have to do is send an email to the sales team at ajirotech@gmail.com, and they would reply to you, talk about your time zone, talk about, and the fee is really quite affordable. Really, it's really quite affordable. It's when you look at it across other tutoring service, I think this is the one that's quite affordable, and you get the very best of service. We also have for the E levels as well, um, and also for the EdExcel. So we have for the Cambridge E levels and EdExcel E levels. Okay, and we have also across the subject mathematics, which is usually the hot cake when it comes to E level, mathematics and chemistry, and then biology. These are usually one of the ones we have in demand always, all the time. Even physics, for E level. So all you have to do, if you're watching this right now and you are interested for a private tuition, then you can do yourself a solid, okay, and send an email to the sales team at ajiro@gmail.com, and they'll reply to you.
So next, it now says, question high V, state and explain whether. When you come across a question that states explain, it will state it without giving a reason. You won't get the mark. And it's also 1 mark. There's no half mark. Each mark is 1 mark. So you have to state, you have to support why you are going for your conclusion. If you state it without giving the reason, you won't get the mark. Nobody gives half mark. So that's when it comes to question like state and explain. You state it. If it were to be 2 mark, state it will take 1 mark. Giving the reason also give another 1 mark. But this is 1 mark. They are together. You must state and explain before you can be awarded the mark. Now, the speed of the car becomes constant. So from this statement, the speed becoming constant. The speed becoming constant. I can see something from here that, so from this statement, speed becoming constant. This one means, so it means the kinetic energy is going to be constant, because you can see, means that kinetic energy, which is AK, is constant. It's not changing. So remains unchanged. Now, but the resistance is not neglected, meaning that the work is still be done against a resistive force, but there is no work done by kinetic energy. So kinetic energy, no work done by kinetic energy. So meaning that kinetic energy is not increasing there. So no work done by the kinetic energy. Now what will now happen? Don't forget that we use the state and explain the output power. So let me call it P output. It is the work done by air resistance plus kinetic energy over time. That's what we used to get the earlier question. So from here now, so that's what we use. So we're able to know. So meaning that work done by air resistance is going to increase. Work will only done. That is, what will be only done, work will be done against air resistance. But kinetic energy, there's no work done against kinetic energy because there's no by kinetic energy because the speed is remain constant. It's not changing, it's not increasing or decreasing. So that's what it means. So what will now happen? It's going to be less, it's going to be difficult. This KE remains constant, it does not increase because the speed is constant. So meaning that we only if that so if at all the power output is to have another power output is going to be less. Why? Because as this one is increasing, work done against the resistance has to increase. Fine. So no work done, the kinetic energy remains the same, meaning that the total work done will decrease because the kinetic energy is now increasing. So that's what happened. So what happened now eventually is going to be the power output becomes what? It's going to become less because the speed remains constant, which does not increase kinetic energy. So it does not increase it. So if it's in that because the speed is constant, so it's like higher because as we move further, we are going to do more work against the resistance. But kinetic energy remains the same because of the speed. So our conclusion is going to be the work done is going to be less than the earlier obtained. It's going to be less than the earlier obtained. So looking from that judging from that formula. So no change in kinetic energy. So it means that the speed, the work will only be done against air resistive force. That means going to be less. So it's going to be less. So it's going to be less because no change in EK means kinetic energy, and work will only be done against air resistive force, and work is done against air resistance or resistive force. Air resistance against air resistance. So that will be question 2. Define moments of a force. Of course, very simple to define, but we do not forget the keywords. That must perpendicular distance. That's all. Perpendicular distance. So that's the only difference between moment and normal work. Normal work means force time displacement, product of force and displacement. But here now, product of force and perpendicular distance. That's the keyword. So that will give us product of force and perpendicular distance. This perpendicular is a keyword, must be there. Perpendicular distance from the pivot. So from the pivot. Now we have this one. It looks like an inclined plane. Not really. A tree of mass 270 kg grows out of a slopy ground and is supported by a post as illustrated in figure 2.1. Okay. Now the ground applies a total force. Okay, that's total force R on the tree at point Q. The center of gravity of the tree is horizontal distance 1.2 meters from Q. So the center of gravity is going to act downward. So that will be the weight. It will hand vertically down from, I think that is the point. So here I'm going to have the weight. So we are going to have the weight here. Let me try it better. So here is the weight represented by W of the tree. Now, this particular force acts here, so we can project it outwards. So this force will be like this. If we project it, it will be like this. Yeah, project this F out. So that's F. So it will look, if I do that, it will look like this. Now, if I want to, normally if I draw an inclined plane like this, so I have an object on a inclined plane, there's an inclined plane. An object is on a inclined plane in this form. The weight acts vertically downward. That will be the weight. Now, this is a force here. This one now, that last slide, you can see now. This one, this is going to give me weight, cos. This is going to give me cos theta. That's called the weight of the particle along the perpendicular to the plane. So that represents, but this one, this time around, is now pointing upwards. So still go with the same thing. But my point is that this angle and this angle is the same thing. So that's what I want to come. That's what I want to know. I want to let you know. It's the same thing. So if it is theta, this also will give me theta. So that's all. So this way, this is called this that way, which is going to give me F cos theta. So I just have to produce it upward to point upward like this, so that it can be this and it can be this way. Because based on the question we have, it has to point like this. So this now is supposed to give F cos theta. Now that's perpendicular. Now, how do we? Okay, let's see. So I'm just comparing with an inclined plane. So it will be this way. Normally, this will give me my normal reaction, but we don't need all this. We don't need it here. So no normal inclined plane. Now, what do we do here? So the line of the perpendicular to the PQ. Okay, this has been told that it's perpendicular. So there's a perpendicularity here from here to here. So that will be 90 degrees. So showing perpendicularity. So that means if I have it this way, I have the force here. So I have the force here, which is F cos theta. And this is the point Q. At this point, I have point Q. So let's take down. So that's a perpendicularity between this and this, which means we can take moments. So after that means, it means we can take moments when there's perpendicularity. Okay. So this is our tree. So this is the tree. I'm to leave it. I just drawing the to draw this way. This represents something like tree. So this line is the tree. This is the tree. So making it clearer. And this point point P, here's the P. I think I okay. Okay, no P. So P, okay, I think P is the somewhere I've drawn on top of it here. Okay, P. So there's a point P this here. So the distance between the is 1 point. So the distance between that from here to here is 1.6 meter. So that's 1.6 meter. So what do we have here again? And as it passes through the okay point P at an angle of this, okay, okay. Then it's in equilibrium. Okay, it's in equilibrium. So by taking moments about P, about Q, we want to prove that theta is 25 degrees. Now, let's talk of this one too. This one, the for W. So you drag it down in your mind. So I can close this place by saying I can close this. So that will make it looks like that. This theta, this theta is the same as this theta. So that will be the same as theta. Now, perpendicular to Q in your mind, you drag. So you just to consider this place. So you have it this way. So this will be our weight. That will be perpendicular to the weight. So we have our weight. Fine. This is W, the weight. Q, this is going to be Q this way in your mind. You drag this point Q down. That is, or as okay, as you extend from this one from here, so you just start from here. So that I can perpendicular to this place. So that will be this place and this place perpendicular. So you start as if the weight start from here. You don't need to start from here, but you actually start from here. But you have to imagine this way so that I can perpendicular to this point. So that's what I've done here. So I have two things now to take moment at Q. Take moment at Q. That means this point, this force is moving like this. It's going to turn like this. And this one will turn like this. So that's all. So each one is, both of them are okay. This one here that you can see my point of marker I represent. That will give me anti-clockwise. So why this one is the second one is clockwise. And we know that the principle of moment says that some of the clockwise moments equal to some of the anti-clockwise moments. So very simple to go. So that's QQ. So let's talk of the weight first. So that will give me the weight. The distance is what? 1.2 from here to here is 1.2. So that's 1.2 is equal to, what's the force of this? Okay, but I need to calculate the distance. Oh, this is not 1.6. Oh. This is not 1.6. It's horizontal distance as 1.6 here, the distance horizontally. So I need to know the distance. Distance here, let me call it X. So we need to know that it is this horizontal one that is the horizontal one from here to here. If I do this way, fine. It is this here that's 1.6 meter. So I need to know the distance, that perpendicular distance X. So how do let's calculate that. So let's first of all calculate that. So let's draw a triangle out from that because we can see this, we can see this, and we can see this way. Can be this and also this one. So I'm looking for this place. So that this I'm looking for our X, and this is 1.6. This is theta. So we also SOHCAHTOA method. Now I can have SOHCAHTOA method cos theta is equal to adjacent 1.6 over hypotenuse, which is X. I can now say our X is 1.6 over cos theta. So that's cos theta. Now that's all. So we have to take moment now. So taking moment now, taking moment at Q according to the question. So take moment at Q. I have weight. So that's the weight is W. That's 1.2. Let me change, if I have to change the color. So take a moment, I have weight, that's 1.2. That's the distance equal to, what's the force of that one? That is F, cos theta. The distance is 1 point. Oh, wait, there's something. Oh, no, this ordinary F. Yeah, okay, ordinary F. According to this question, they have they call it F. That this line has been referred to as F. So like F is going to be like it's ordinary F. So they have to be labeled as F. That F, that mg cos theta here. This is supposed to give me normally this is giving us a weight cos theta. So it's represented by F according to the question is F. Now we have so that F, the distance is 1.6 over cos theta. So inputting the figure and work it out, let's say W, that will give me, so I'm looking for F, cross multiply, I'm making F the formula. I think it will give me, so that will give me W 1.2 times cos, that will cos, oh, I'm looking for cos, so let me make first the formula. So that will give a, okay, let me still make use of this space. That will give me this, okay, that will give me F. So cos in this case, cos theta will give me W, that's 1.2, 1.2 W. No, that will give us 1.6 F divided by 1.2 W, 1.6 F over 1.2 W. Yeah, I think that's correct for making cos theta the sort of formula. Yeah. So let's substitute the value. So I have cos theta will give us 1.6 times value of F is 1008 over W is the weight 1.2. W is mg. The mass is 270. So you have 270 times 9.81. Don't forget that's our gravity, 9.81. So if I have to press this, so if I have to use cos inverse, so that our theta will give us cos inverse of 1.6 times 1800. Everything over 1.2 times 270 times 9.81. So the press calculator, so that will give, so let's see what's going to give in calculator. So we have cos inverse. So let me press calculator and see what it gives. One point six. One point two times 270. So here, from here, it gives 25.03, which is 25 degrees as required.
A lot, and you're like, okay, do you have a private tuition? Don't you have? Do you have? And yes, Ajiro Tech do have a private tuition. So by my right, you can see that we have for the EdExcel and Cambridge IGCSE, and yes, we do have for all subjects. Okay, all subjects. Okay, the popular ones that's always been in demand is mathematics, English language as a second language. Okay, we have physics, we have biology, we have chemistry, and we have um, you know the flagship, which is ICT, just here and there. We also have business studies. So if you're interested for a private tuition, I think all you have to do is send an email to the sales team at ajirotech@gmail.com, and they would reply to you, talk about your time zone, talk about, and the fee is really quite affordable. Really, it's really quite affordable. It's when you look at it across other tutoring service, I think this is the one that's quite affordable, and you get the very best of service. We also have for the E levels as well, um, and also for the EdExcel. So we have for the Cambridge E levels and EdExcel E levels. Okay, and we have also across the subject mathematics, which is usually the hot cake when it comes to E level, mathematics and chemistry, and then biology. These are usually one of the ones we have in demand always, all the time. Even physics, for E level. So all you have to do, if you're watching this right now and you are interested for a private tuition, then you can do yourself a solid, okay, and send an email to the sales team at ajiro@gmail.com, and they'll reply to you.
Now, got this, draw the label. Okay, draw a label scale. A label scale. A label is scaled. Scale factor triangle to represent the forces acting on this. So there are three. There are the first one is here. There's a total force sounding like a resultant force here. There's F and also weight. So if you look at it, how does a wave act? Wave acts to the left. You can see this is this F act to the left. Weight as already the weights has been drawn according to the question. We want to complete it. So this one will have to the left. You can see now. So you can see this is the from here to here, a straight line. So this, so that will give our value of F as 1800. Now, the angle between the F, that's theta. The angle between F and the vertical line is 25. This is our theta. Because you can see now it's from here. You can see here is theta, this is theta, and we have gotten to be 25. So what do? You are going to take your protractor. So you complete it there. You take your protractor from here to here, you measure 25 degrees. So let's say this 25 degrees. So when I'm just using my eyes, you use 25 degrees to vertical. How long is going to be? It's going to be longer. It's very simple to do here. This is what I'm going to do. I can't actually measure it from here because it's going to be, if I enlarge my screen, it's going to be different. So on the paper question given, you take a ruler to take the measurement from here. Let's say this point and these points. So measure the whole length. So whatever it is equivalent to, want to know how long it's going to be. So let me label this as AB. So measurement of AB. So this one means that the weight, what's the weight first? So the weight, let me calculate the weight normally. So weight is mg. So let's know. So that will give you 270 multiplied by 9.81. So the calculator, so 270 multiplied by 9.81. So it's actually 2648.7. As usual, this is two smaller figure. This is 3. This is 2. 2 is the lowest one. So that will be 2600. That will be 2600. 2600 weights Newton. Now, this is what you will do on the question paper, please. You measure the length of AB in that question paper. You measure the length of AB. So let's say our AB correspond to this force of that AB. 26. Okay, this is 0. So correspond to 2600 newtons. Now, what will the force of 180 equivalent to? Force of 180, what will it be, the value? I want to know so that's how to know the length. So 180, what will it be? Put it here, 1800 newton. So what will it be? Equivalent to what? Put it, you can call it X. Then what do you do? So in this case, it's going to give me our X. So I want to see X. So that will give me our X will give us 180. Then AB, the length of AB over 2600. So whatever this is, so this is in this case, so this is the AB. So you measure the length of AB with ruler. So let me write it here. AB is measured with. So whatever you get, put it there. Just measure AB. Then look for X. So our X is telling me how long this line is going to be. So this line is what I call this line. This, okay, let me put it here. This represented by, so is represented by X, the length of that line. So how long? So that's how to know how long. So when you do that, you will now join it together here, complete it here. Fine. So my own, I just say stop here. So whatever you measure there, that's going to be. If I use ruler on my screen now, I can't get the perfect answer because if I reduce the size of this, the font of this, decrease the font, it will give me something different. If I see something different, but the question paper is the same thing. So that's the person. Now, when you do that, so you now you label this, whatever angle you got here, whatever angle is being up. Here is also labeled as 25. Here is labeled as R. How is going to be? The arrow is going to be like this. It's going to be up. It's going to be up. The arrows will follow each other because it's in equilibrium. You can see now. See the arrow. You follow. So I think you start from A, then move to B. You are moving like this again. So when now you move again, it will follow each other. So that shows that it's in equilibrium. So that's going to be. Now, the three exact prayer of this on the top of the post. Let's go to the post. Okay. This is the post. This is the force on the post. You know, pressure means perpendicular force over area is perpendicular force per unit area. So what's the force perpendicular? This is F. You can see now, this is the post. So F here, this one is perpendicular to the post. So it's perpendicular. So we are using ordinary F, not F cos. This F is perpendicular to. So that's a pressure mean perpendicular force over area. So going to give me perpendicular, that give me F over area. So we are looking for, so A will give me 4 over P, and that force is 1,800. This is a 15, then 000 kilo means 1,000. Now once divided by 157, 123. So it's giving me 0.012. So it's totally correct. So this is 2. This is also 2. 1, 2. 2 is the ground. So that's perfect. Now, question 3. I think this okay. Question 3 is on waves. So the question 3, two progressive waves. No, two progressive water waves, X and Y, travel along the horizontal line, a straight line from point A to B. Okay, point A to B. The fluctuation of displacement of the waves with distance from, okay. So we have displacement against distance, which means that the distance from between this, the distance along this line, that will give us the wavelength. What is the displacement against what? Against distance. The distance along this, look at it. So distance along this vertical, the horizontal distance will represent displacement. Wavelength. If you are to be displacement against time, the horizontal distance will represent period. But now we have displacement against distance, meaning that this horizontal distance is we are going to have wavelengths along the horizontal distance between the cycle. Now we have this. So state the amplitude of x. Or this is direct. Amplitude means maximum displacement from the equilibrium. This is the maximum. This is x from here to here. So that will be from here to here. So that what we are looking for. That is 10 centimeter. So it's 10 centimeters straight. Now both waves have frequency. This same frequency. Let's even know they have the same frequency, meaning that they have the same period. Because we know that period is 1 over frequency. As long as they have the same frequency, automatically they're having the same period. And those two waves, they are said to have constant phase difference. Why do I say so? Because that means they're coherent. Because when two waves have same frequency, they are said to be constant phase different, to have a constant phase difference. And when two waves have constant phase difference, it means those two waves are coherent. So that's the result of coherent wave. Coherent waves are waves with constant phase difference. So that's what we know. So when you're working to waves, there are things that you know from the information given. Now, here, the question says they have same frequency. Automatically, they have same period. Automatically, when they have same period, it means they have constant phase difference. Then it means they are coherent. When two waves have constant phase difference, automatically they are coherent waves. Okay. Determine the period, the speed of x of the x. Okay. Same period, same frequency, same period. So like I said earlier on, this stand horizontally represent the wavelength. So represent the wavelength. Now, if you let go by that method, so for which one? For x. So what is the wavelength for x? So I mean from here to that's a point. That's a cycle. A cycle for m from here to here. So this from here to here. Let me try to change. So I can wipe up this. So we need to identify a complete cycle. That means from here to here. It's a complete cycle. You can see now this to this guys. So meaning that the wavelength is 0.4 meters. So I have to take out the unit. Wavelength is 0. What distance between something like this? So distance between this is called a wavelength. If it's distance. If it's also called a period, if it is time, that is horizontal. If the horizontal is labeled as time, so that will represent period. The horizontal line labeled as distance. That means the wavelength. So distance is a wavelength. So in this case, so our wavelength is 0.4. Wavelength of x 0.4. So don't forget we have speed is equal to what? F lambda. So meaning that 116 multiplied 0.4. That's 6.4. 6.4. So that's 6.4. Now, what again? State and explain whether X and O, they are coherent. Oh, it's even here. So they are coherent. Automatically, they are coherent. Why? Because they have same frequency means constant phase difference. So state it coherent. Yeah, they are coherent. Because they have constant phase difference. So in the bracket, same frequency. So you've learned now when two waves have same frequency. So coherent two waves are the way with same frequency. So that's another way of putting it. Constant phase difference. And waves have constant phase difference because they have same frequency. That's all. Okay. So the wave X and Y and wave Y supposed to superimpose to form a resultant wave. Okay. Now I want to now scale resultant displacement against distance. Let's go back to this and see. So resultant displacements can wipe away this. So resultant displacement means that what's called sum of the individual displacements at any point. Let's start from the beginning here. Look at this. This is Y. So amplitude of Y, it is minus 20. Amplitude of X is 10. Resultant amplitude now. So what's the resultant amplitude? Amplitude arrow for resultant. You had it. We had amplitude together. So that will give me amplitude of Y plus amplitude of X. So meaning I'm going to have minus 20 plus 10. So that will give me minus 10. So that will give me minus 10. So on the first one is on negative side, minus 10. So if you do this one too, if you do the second part, you're going to get plus 10, minus 10. So automatically, the result displacement for this one is going to give me, so plus labeled is going to give me minus 10. But this one is going to give me plus 10. Here to minus 10. On this side, plus 10. On this side, minus 10. That's going to be. So we know how the graph is going to be now. So we are starting from the negative axis of minus 10. So here is going to minus 10. So minus 10. On this side, plus 10. On the second one here, this. On the next one, this. And on this one, this. So that's all. So that's how we are starting from 0 here. It's going to be inside. So it's going to be on this. So just sketch. So this is perhaps just a sketch. That we're passing through this. So that will represent the graph. Now, use the intensity of X is this, that of Y is this. So to even start with here, don't forget that intensity varies as well amplitude square. So if I do this one in mathematics, that will give me intensity 1 over amplitude 1 square, intensity 2 over amplitude 2 square. So I want to change it to X and Y now. So I'm looking for, okay, that's okay. Normally it's supposed to be this, but let me change it to X and Y now. That's intensity of X1, amplitude of X squared, intensity of Y, amplitude of Y squared. So what are I looking for? We are looking for intensity of X over intensity of Y. The math is this already, that means is going to give me amplitude of x squared over amplitude of y squared. Now I can also do mathematics by saying is amplitude of x over amplitude of y all squared. So that's my maths. So I remember amplitude of x is 10. Amplitude of this minus, if you square minus, you're going to get positive. So you don't need to write negative again. That'll give me 20. So squared. So that should give me 0.2 because that's 1 over 2. I think 0.25. 0.25. Now we have a collision question here. A small ball is dropped from rest from a height h1 above the ground and forced vertically downward. The ball collides with the ground, bounces back vertically upwards, reaching maximum height. So this maximum height, so you should know V is going to give me 0. When it's coming down, U from height coming down, U is 0. So here for the coming down vertically downward, here also represent V U is 0 for the first part. For the second part, now we have the state and explain whether the collision is what is elastic or inelastic. So we use two methods to verify that. We can use kinetic energy. So when it's coming down, okay, not okay, we are not yet there. The ball up this is constant with it for this, okay. So just the ball before it hit the ground, we have this. When it's leaving, we have this. So here is now for this is our U now for it to the okay, we are constantly coming down. This is when it's going up, okay. For coming down, for this one, so for this one is U, it's 0. Our V is 5.2. That's fine. For this part is going up at maximum height. That's maximum height. Our V here is 0. With our U 3.6. So automatically it's going to be what? Relative speed of approach. It's called relative speed of a separation. We can use that on all kinetic energy. Automatically it's going to be inelastic. Why? Because the same mass, the same objects from kinetic energy, which is mv squared over 2, they can never be equal. Look at the view of this one, look at the view of this one. So we are using V as 5.2. Here is going to be our V 3.6. Automatically, kinetic energy can never be equal. So that's going to be inelastic. So it's going to be inelastic. Inelastic. Because kinetic energy before is not equal to kinetic energy after. PK means kinetic energy. So that's what my circle. Before is not equal to kinetic energy after. So after collision. So it's inelastic. Calculate the change in momentum of the ball. Now, let me put it through on something here. Note that when an arrow is moving to right, is having a positive momentum, positive velocity. Arrow moving to left is having negative velocity. So arrow moving down is negative velocity. Then if it's moving up, positive velocity. So take note of this one. Take note of that. I will wipe it up at least. So take note of that. So from here, we know what to do. So we are calculating change momentum. So we only have the velocity, two velocities here. So take note of this. Now for the two, this one is this will be my U now. That will be my U here because this is only when it's like it's leaving. That will be our final. So we are considering the two together. So this is our U when it's coming down. This is before colliding. This is after colliding, that's the final. So looking like that, our yield is minus because the arrow is downward. Is minus 5.2. 5.2. Our V is 3.6. Then change in momentum. So that will give me M. That's the final minus initial. If you put that, M is 0.25. That will give you 3.6. So that's 3.6. So 3.6 minus 5.2. So automatically that will give 0.25, then 3.6 plus 2.5 or 5.2 plus 5.2. Let me write it here. So it's giving 0.25 and 3.6 plus 5.2. Now, putting into calculator. So putting calculator is giving me it's giving me 2.2. So putting in calculator 2.2. Now moving up from it, we are looking for average force. Force is change in momentum over time. So 2.2 over the time is 0.18. 0.18. So putting into calculator, that will give me, that gives coming 2.2. So that's actually 12.22. The lowest 22. So we're looking for 2 tsunami. That's 12. But the lowest one is 2 tsunami from the data. So that's the method. So we're looking for the ratio of the height. Okay. So let's say downward, when it's coming downward. For downward, yield is 0. Our V is 5.2. Yeah, 5.2. Okay. So from here, V squared is equal to U squared plus 2GH. So let me call it H1. That's the first one. So meaning that our H1 here will give me U the circle, that will give me 5.2 square over 2G. So the next one, upward, that's upward. When it's going upward at maximum height, V is 0. Our U now give me 3 point, is it 3? U is 3.6, okay. 3.6. 3.6. So applying that to the same thing, U square, that will give me U square. That will be minus because you are going against gravity. So that will be 2GH. That means that's a common H2. So H2 will give us, this is U the zero, V this negative also will come because this is zero, that will move in. So that will give us 3.6 square over 2G. Yeah, the ratio now of 1 of 2, that's 30.6 square over 2G divided by 5.2 square over 2G. So turn it to mathematics. So that will be times, that will give you 3.6 squared 2G multiplied by 2G 5.2 squared. So eventually we are going to have 3.6 over 5.2 all squared. So let's see what calculator will give. So it gave me 0.48. But it's also two similar figure too. That's 0.48, 0.48. So that solves that. Question 5. Your modulus. Your modulus means stress per unit what? Strain. So this just stress. You can just write stress like you can write like this as stress over. So we are good to go with that. Yeah. So want to determine cross section area. Okay. Let's derive something here of. So let's do something here first. Okay, we have stress as force over area. We have strain as extension over length. So we have your modular as T's over T's. So we can do that. So that means your modular is going to give me force over area divided by x over original length. So applying mathematics, your modular is force L over what? AX, which I can say force over X brackets L over A. But F over X is spring constant K. So I'm just deriving the formula in K. You may come across something like that too. K. So meaning that our Young modular is the K, then L over area. That's all. K is the spring constant, which is the gradient. K is the gradient, spring constant. So let's calculate K first. So we're looking for A. So that means our A. So that will give me KL over your modulus. So that's all. So K is the gradient of the graph. Now let's see. So 0 to the highest. So that's 500. Look at the units. It's units of business square, right? That will be 500 minus 0. 500 minus 0. Look at this one too. That will give me on 4. 4 minus 0 exponential minus 3. So that will give you 4 minus 0 exponential minus 3. So let's see what K is 500 divided by 4 divided by exponential minus 3. Okay. So K is 1, 2, 5, 1, 2, 3. The lowest one is, if you look at, okay, 1. Put in as 1. Okay, we can say like 1 point. Okay, that's our K. Okay. Now to now put the variable. So we're looking for A. A will give us 1, 2, 5. That's about 1.3 exponent something. So 1, 2, 5 is 2, 3. Then times length. Original length is given is 0.18. Is 0. No, 8118 is 0.81. Okay. 0.81. Your modulus is 95 giga power 9 exponential 9 giga. So 9, I'll give it 95 exponential 9. So let's see what it gives in the calculator. 95 years, correct? So let's see what calculator have for us. So it's giving us 1.1 exponential 6 minus 6. 1.1 exponential minus 6. Finances.
A lot, and you're like, okay, do you have a private tuition? Don't you have? Do you have? And yes, Ajiro Tech do have a private tuition. So by my right, you can see that we have for the EdExcel and Cambridge IGCSE, and yes, we do have for all subjects. Okay, all subjects. Okay, the popular ones that's always been in demand is mathematics, English language as a second language. Okay, we have physics, we have biology, we have chemistry, and we have um, you know the flagship, which is ICT, just here and there. We also have business studies. So if you're interested for a private tuition, um, I think all you have to do is send an email to the sales team at ajirotech@gmail.com, and they would reply to you, talk about your time zone, talk about, and the fee is really quite affordable. Really, it's really quite affordable. It's when you look at it across other tutoring service, I think this is the one that's quite affordable, and you get the very best of service. We also have for the E levels as well, um, and also for the EdExcel. So we have for the Cambridge E levels and EdExcel E levels. Okay, and we have also across the subject mathematics, which is usually the hot cake when it comes to E level mathematics and chemistry, and then biology. These are usually one of the ones we have in demand always, all the time. Even physics, for E level. So all you have to do, if you're watching this right now and you are interested for a private tuition, then you can do yourself a solid, okay, and send an email to the sales team at agile@gmail.com, and they'll reply to you.
Now the extension is now this. Determine the work done. Okay. It should be around okay from what? From 2 to 3. Let's go over to the graph. 2 to 3. That should be 2 here. 2 from 2 to 3. Okay, what's the value here? Let's read the value from here. It will be around that the graph, around that the extension time graph, extension what? The first extension graph. So this is this. So here should be, I think it's 250 on 4. No, on 3. 3 is the middle of this line. The middle is yeah, in the middle of this line. So where is the value here? So each one is 10, 10, right? Yeah, 10, 10. That's 350, 360, 370, 375. 375. That's all. So this is a trapezium. So from here to 3 here, if you look at it now, that will be a trapezium around that the graph. See, this is a trapezium. So it's going to be a trapezium. If we put it out, so I will turn it the other way around. Trapezium is going to be this way. This is the height, which is 1. Exponential minus 3. So that's the height. 1 exponential minus 3. 1 is 250. That will be 250 here. Here it will be 375 here. So that's going to be A plus B bracket H over 2. That will be the work done. Right under the graph. So that will give me 375 plus 250. Then bracket 1 exponential minus 3. Then everything over 2. So let's see what it gives from calculator. 0.3125 is giving 0.3125. Don't forget. So taking into that's 0.31. 0.3. So you can put 0.31. So it's 0.31. Well, that will be 2. So this one, you might not even run this one. You might leave this one out. So you don't let this one to confuse you. Leave this one out times 3. So the lowest one is 2. Leave this one. This is the lowest one we got, which is 2. So that's why I leave it as 2. Lowest one is 2. So move uh, to question 6. Define the potential, so electric potential. So that's work done per unit charge. Right? So potential, so it's energy transfer per unit charge. Since 1 mark, can go further, but energy transfer per unit charge. Now, if you go through this, you are free to contact the admin. So any clarification, anytime you have a question, he will get back to me. So he will get back to me. So can explain it further to different topics. By the time when I'm just working based on the question we have. Yeah, you're still going to see more of it in multiple choice as well. And for the A2, the P4, the P5, how do you go about it? Now we have a circuit contains 4 resistors, a battery of electromotive force EMF with negative no internal resistance. You will know if there's internal resistance. The question will be this. I'll put this dot line here. So this one means there's internal resistance. So that dot, anywhere you see anything that says that dotted line, it means there's a presence of internal resistance, and that will affect. Yeah, it has effect on terminal PD. Because the more that internal resistance, the lesser the terminal PD. Well, let's leave it that way because it's not contained in this question. So when the variable resistor, this variable resistor, all these, the 3 of them are fixed resistors. The current is this so I1, I2, okay. But my method first, to start with, let's distribute EMF. This is the parallel. This, in parallel, this. So the value of this is 8 volts. This also 8 volts. This also 8 volts. Why? Because in parallel says same PD, different current. So meaning that these 8 volts here, both 210 and the resistor of R, they are sharing the 8 volts. 430 ohms and 240 ohm, they are sharing 8 volts. So the two of them, the voltage across 430 plus 240 is equal to 8. PD across 210 plus PD across variable resistor is 8. So that was the means. Determine the charge, okay? Charge means Q is equal to high T. That will be total current in a second, which is 0.03 multiplied by the time is 4 converted to seconds. That's 60 minutes. So that gives 7.2. That gives 7.2. 7.2. Confirm that 0.03 multiplied by 4 multiplied by 60, 7.2. Now, determine the current high one. So we can, so here we can make use of this one. So I1 is across for the total PD, total resistance across. So to calculate I1 means we make use of this 430 in series, 240. That's 670, right? 670. That's total resistance, 670 ohms. Then Ohm's law say V is equal to IR. I'm looking for I, which is our I, what they call it, I1 across that. That will give me, which is 8 over 670. So 8 divided by 670. So that is 0 0.0. I mean, this is 0 0.012. Is 0 0.012. To calculate the height too. So I2, very simple. So total current now, to calculate I2, I total is going to give me I1 plus I2. So that'll be that. So meaning that our I2 is 0 0.03 minus 0 0.012. So that's will give me 0 0.018. That is 0 0.018. Determine the resistance that's yeah, we are making use of R. So come back to this one. So that this and then associated, that will be 210 plus R in series. So the result of this is going to give me from a half 210 plus R total resistance. V is equal to IR as well. V is 8. I of that one is I2, which is this. So this total resistance here. So this is 8 is equal to 0 0.018. Total resistance is 210 plus R in series. So I can work by say 210 plus R is 8 over 0 0.01. Yeah, just follow your method of solving normal equation mathematics. But I just follow by I prefer this. So eventually, so R will give me is 0. That's give me 0 0.018 minus 210. Calculator. So putting the calculator, that's 234.44. So 234.44. So 23, that will be 230. So 230, oh sorry, 230. That's 230, 230 ohms. So question D now. Okay. The favorite resistor, this is fitted with a scale so that the resistance can be accurately determined. The resistor of resistance 240 is now replaced by something else. Okay. The question say with reference to the resistances, explain how. Okay. So the first thing is that when this the galvanometer is 0, it means that the ratio of this and this must equal to radius and this on this side. So ratio on this side. So when the reading of galvanometer, that is current, is 0 ampere. When is 0 ampere? Or let me just say, when is 0? When is 0 ampere? It means that the ratio of the left hand side resistance must equal to the ratio of this and these are equal. So that's so when they are equal, you go to cross multiply and calculate it. Right. Just like it's going to be like this. Ratio of resistance 210 over resistance 430 is equal to resistance variable resistor of variable resistor then over resistance X. So we're able to then from them we're able to come now and find it out. So question 7, fundamental particle. What is fundamental particle? It's a particle that cannot be broken into smaller particles or that cannot be divided into smaller particles. That's the fundamental particle. So in the history of that one, we have we have what's called electrons, we have leptons, we also have what's it called this one say? So okay, we have barium and different types. We have six flavors of quarks. We have up, down, top, bottom, charms, and so on and so forth. A fundamental particle, a particle that cannot be divided into smaller particles. Smaller particle. That's a fundamental particle. Here, a nucleus has nucleon, X. So here, so let me just use something like this. Let me just use something like this as X. So 4, that's 14. 14. Here they call it P. Fine. The ratio of the charge to the charge to mass. Here, this 14 now mass. Here, mass is 14 U. Don't forget that charge is P. E. E is the elementary charge. E is equal to 1.619. U, elementary charge is U. U is atomic mass unit. I think 1.66 minus 21. 27, it's minus 27. Anyway, it's in the front page. So let's check. It's minus 27 gram. So let's hopefully find out. But that's it. But just don't need to worry yourself. You see, they also say that elementary charge. So that's all. Now we have mass from here. This charge over mass, So that's give us P E over 14 U. That's charge over mass. And that's given as 4.17. So we're looking for P. We are looking for P. That means cross multiply. So that means P will give me 14U times 4.1 power 7 over E. So if you do that now, so that will definitely give us this, will definitely give us 14 times 1.66 power minus 27, then 4.1 power 7 over 1.6 minus 19. So let's see what it gives in calculator. So in calculator, it's giving 5.9, okay, 5.95. So you cannot, so you can't get own decimal. That will be 6. So the answer is 6. So the answer is 6. So to balance it, now the question said the nuclear this or the okay beta minus. Don't forget when you want to produce beta minus is going to form electron and neutrino. Electron and neutrino. If we are producing beta plus, it is beta plus going to form electron neutrino. Beta plus is going to form a particle called electron neutrino. But beta minus is to give you electron anti-neutrino. Electron anti-neutrino. So let's see. So Z is there. Okay, this is the beta plus. So that will be beta minus. Don't forget it's going to give you is 0 and that will be minus 1. Is electron anti-neutrino 0, 0. I did the symbol, something like this. That's electron. No, that will be a bar. So that's also anti-neutrino. A bar on top. So how do we balance it now? Here is 6. Okay, we got 6 here. So this must be 7. 7 minus 1, that's 6. This should be 14. 14 plus 0, 0, 14, 6. 7 minus 1 plus 0, I think that's the balance. That's the balance. So just know that when you are forming beta minus, so it leads to electron anti-neutrino. If it's beta plus, it will form electron neutrino. So electron neutrino, that means there's no bar on top. So it's not a bar on top. So that's it. Now, this one says, now a sample of radioactive particle are possibly charged. Oh, possibly charged. That's number one. And have continuous range. Oh, continuous range of energy means it's a property of beta particle. So take notes here. So continuous range of energies indicates beta particle. So that's what it means. State and explain whether the particle is a what? Either alpha, it's not alpha particle, either beta plus called positron. Beta plus called positron. And when you are forming it, the decay of it leads to electron neutrino. So beta minus is an electron. Decay of it leads to electron antineutrino. So meaning electron antineutrino, this electron neutrino. So that's different. The one that has bar anti, the one that's not have bar narida. So we've seen the two keywords, possibly charged. So automatically it's going to be alpha plus. No, that one not even let us know. Let's use that one. That one. Possibly charged means at the same rate of what? Range of energies. It means not alpha. So it's between. So range of energy is saying that it's between. Being a range of energy is between alpha minus and alpha plus. Sorry, beta plus. That's what it means. So this what this one is saying. Range of energy. So this one is linked to these two. This one indicate that it is either these two. Possibly charge automatically now brings out. So this possibly charge indicate that it is what is the beta plus. So that's all. So that's what it means. So it's a beta plus. So this, okay, I will leave it that way, but let me wipe it out. So that's what coming. Let me put it. This one say either this or this. No, that is not even, is both of them. This one representing both of them. That statement. The statement of positively charged here, let me do it in another way. The statement of positively charged so that one corresponds to beta plus. So this one is corresponding to this. So that one indicate this. So that's indicate. So automatically the answer is out now. So what do we do? What do we say? So it is a what? State is what? It is beta what? Beta plus. That's point one. Why? Beta plus. So because what? Range of energy indicates beta particle. Beta. And what? Positively charged beta plus. So that's all. So that's what it means. I think that's all. So we come to the end of this paper. So this is May 2025 paper 2. So thanks for listening. Still more to come. Thank you. That's all. Bye for now.